Welcome once again, bizarre creatures enthusiasts. As we embark on a meticulous, comprehensive biological investigation into the sophisticated camouflage and sensory mechanisms prevalent within the planet's most isolated, specialized, and endemically rich ecosystems, the dense Ituri Rainforest of Central Africa, our subject today is the Okapi, a stunning, medium-sized artiodactyl whose very existence in the dense, high-humidity, low-light forest floor is predicated on extreme cryptic coloration and phylogenetic uniqueness. The Okapi presents an unparalleled masterclass in evolutionary lineage, employing a combination of elongated neck vertebrae, ossicones in males, and specialized limb stripping, cementing its status as the sole, non-giraffe member of the Giraffidae family. The foundational element of their survival strategy is the alarming morphology of the tongue, an incredibly long prehensile dark blue organ, which is not merely an eating tool but an intricately engineered sensory and hygiene device. Chemically speaking, the musculature controlling the tongue allows extraordinary extension and manipulation, enabling the Okapi to perform a crucial self-grooming function, notably reaching deep into its own ears and eyes to clear parasites and debris. At the critical level of foraging behavior, the Okapi exerts its effect by binding tactile input with chemical avoidance, using its specialized, thick tongue to strip leaves from branches while simultaneously testing for toxic plants, which form a crucial part of its diet. This binding event is catastrophic for the specialized, often poisonous plant prey because the animal is able to consume it without fatal consequence, completely overriding the plant's sophisticated chemical defense mechanism. The resulting continuous, uncontrolled browsing allows the Okapi to access food resources that are toxic or inaccessible to almost all other major rainforest herbivores, causing persistent and forced exploitation of the deep forest niche. This overwhelming, highly focused feeding strategy rapidly leads to severe central nervous system disruption for the plant, resulting in immediate systemic paralysis, followed inevitably by catastrophic, unsynchronized ingestion by the specialized browser. The historical context of this morphology is critical. The Okapi remained largely unknown to the Western scientific world until 1901. Primarily due to its extreme elusiveness and the dense, inaccessible nature of its endemic habitat, earning it the moniker African unicorn. Their method involves a deliberate, non-lethal, yet highly efficient probing of the dense undergrowth, allowing the precise collection of high-nutrient forest foliage, a perfect example of sustained ecological utility through morphological innovation. The most profound biological enigma surrounds the animal's coat. Despite its visual distinctiveness, the coat is covered in a specialized, oil-based secretion that repels water and prevents the catastrophic breakdown of skin and fur in the perpetually wet rainforest environment. This specific anatomical specialization within their integumentary system essentially renders their entire physiological system chemically resistant to chance, preventing the fatal energy expenditure that affects every other generalized herbivore. Crucially, the Okapi does not engage in extensive herding. It operates purely as an ecological anchor, systematically utilizing micro-reservoirs of high-nutrient foliage to fuel the massive metabolic demand of its specialized diet. Focused ecological research has definitively linked the Okapi's social structure to the prevalence of specific dense trails, primarily marked by specialized interdigital scent glands on their feet, which function as communication depots in the absence of visual cues. This highly specific trophic cascade implies that the ultimate energy precursors likely originate in the unique plant life of the Ituri, are then ingested by the beetles, and finally concentrated by the bird. A triple-layered ecological dependence. This highly specific behavioral structure implies that the ultimate communication signals likely originate in the unique chemical composition of the foot glands, and are finally concentrated by the animal a triple-layered ecological dependence. The okapi has evolved specialized, densely packed, hair-like feathers distributed across the entire body, which function exclusively as secure, permanent insulation depots for heat and specialized protection against the nightly jungle elements. The okapi has evolved specialized, densely packed, oily, chestnut-red fur distributed across the dorsal surface, which functions exclusively as secure, permanent camouflage and specialized protection against the nightly jungle elements upon even minor mechanical stress or perceived threat. These animals instantaneously utilize their massive ears and specialized tongue for balance and detection, creating a rapidly effective, ready-made sensory mantle that deters any potential intrusion attempt. This critical observation provides irrefutable evidence that the okapi's powerful survival is an environmentally determined phenotype, inextricably linked to the unique, complex structural composition of the dense Ituri habitat. The loss of its specialized rainforest habitat and the introduction of illegal mining and poaching presents a dire, dual existential threat. Not only is the animal losing its physical home, but it is simultaneously losing the entire biochemical supply chain essential for its specialized feeding mechanism. The incredible diversity across the Okapia genus shows a profound singularity. The okapi is the only surviving member, a fact which reflects the precise, localized dietary specialization of this particular species. Beyond the aggressive foraging, the okapi exhibits surprising degrees of obligate parental care, with the female vigilantly guarding her single calf against desiccation and pathogenic fungal infection for weeks after the calf is born. The dedicated mother undertakes the arduous, dangerous task of constant provision, navigating the forest matrix to locate isolated, predator-free micro-reservoirs of high-quality food. In certain individuals, the animal exhibits an extraordinary level of maternal investment, leaving the calf hidden for days while she forages, only returning briefly to suckle, a behavior known as hiding. This high investment in offspring survival, contrasting with the animal's solitary, intimidating presence, beautifully illustrates the profound and often paradoxical evolutionary pressures at play in complex, high-mortality environments. The specialized prehensile tongue and grooming behavior itself remains a cornerstone in modern biomechanics, providing a perfectly calibrated, highly selective probe for studying the kinetics and structure of specialized sensory perception in human olfactory systems. By meticulously studying the grooming patterns and chemical analysis, scientists aim to design specific sensor systems or novel synthetic tools that could revolutionize the detection of subterranean resources and environmental toxins. By meticulously studying the okapi's specialized coat oil and chemical composition, scientists aim to design specialized water-repellent fabrics or novel, synthetic systems that could revolutionize personal protection in tropical environments. The chemical arsenal of the okapi's scent glands collectively represents a vastly unexplored behavioral reservoir, holding untapped potential for developing new classes of biomimetic systems focusing on territorial marking and low-light communication. The evolutionary phenomenon is further confirmed by the discovery of similar specialized scent marking techniques in unrelated species, like certain deer and antelopes, reinforcing the concept of a shared behavioral and ecological sourcing strategy. Their unparalleled combination of extreme bizarreness, profound specialization, and specialized ecological dependence solidifies their status as one of the most enigmatic and scientifically crucial organisms on Earth. This intense scientific breakdown should leave no doubt that the most bizarre, visually shocking inhabitants of our planet frequently wield the most powerful, meticulously engineered, and deeply mysterious biological secrets. Now, we turn the focus back to you, our dedicated audience. Following this deep exploration, Which other creature possessing extreme, bizarre, or unique skeletal or behavioral properties should bizarre creatures investigate next? Please share your suggestions for future topics, along with any specific questions you have regarding the okapi's tongue function or its specialized scent marking process in the comments section below. We value your critical engagement. If you found this granular, scientific dissection of the okapi and its ecology informative and stimulating to your curiosity, please take a moment to hit that like button to significantly support our specialized content production. Ensure you are permanently subscribed to the Bizarre Creatures channel today for continuous weekly updates and in-depth scientific narratives on the world's most incredible and often misunderstood animals. Critically, remember to activate the notification bell, guaranteeing that you are immediately alerted the moment our next exploration into the profound mysteries of the natural world is released. Thank you for joining us for this highly detailed session of Bizarre Creatures. Stay intensely curious, and we will continue the relentless pursuit of the world's most shocking biological truths together.